Hello everyone, Sumit this side. Welcome to the Data Engineers Club. So we are back with another mock interview. Now this interview would be taken by Ankur, who has already conducted a few interviews earlier, and we have received amazing feedback about the interviews he has taken. So Ankur works in KPMG Global Service as an assistant manager. He has more than 9 years of total industry experience with more than 7 years in big data. So he's an amazing person, amazing mentor, and a very good industry professional. Now, on the other side, the person who would be attending the interview would be Srinivasan. Srinivasan is working in Honeywell as a data engineer. He has a total of 2.5 years of experience, and the interview would focus around Apache Spark, Azure, and a lot of project related questions and scenario based questions, which I feel everyone wants to know. So, this is going to be an amazing interview. Stay tuned, keep watching, and I'm sure you would like it. Let's start with the interview.
Hey, hi Srinivasan, how are you?
Yeah, hi. I'm doing great. How about you?
Yeah. Oh, first of all, thanks for attending the session. And let's start by understanding what kind of work you are doing currently, data engineering, your current project, your tech stack, and your experience.
Yeah, so basically, I've been working in my current organization for the past 2.5 years. So I predominantly work on Databricks. Like my day-to-day activity involves in developing, maintaining the pipelines that I have developed. So the current project right now, what I'm working is on power prediction of buildings. So like the use cases, let's say we have a building, so we have like a lot of meters associated with a particular building. So all these meters would give up some readings, right? So these readings are like the power demand values. So like our use case is to predict for the particular building for the next 24 hours what would be the ideal power demand, so that we can make our changes accordingly and save costs on it. So
Mm-hmm.
right, the meters data is getting flowed via the IoT through the event hubs into our Databricks layer. So we actually collect those data, and also we get our weather data from one of the party vendors, like it's called as the tomorrow.io. So basically we get this meta like this weather data and this meters data, and we run it over one of the ML models, and we try to predict like what will be the power demand for the next few days. So this will ideally help us in saving costs on it. So this is like the basic outline of the project which I'm currently working upon.
What kind of technology you are using, and you can explain the data pipeline architecture of
Yeah.
that project.
Yeah, sure. So I am using Azure Event Hubs to orchestrate the data from my IoT servers into my Databricks layer. So we are
Mhm.
having this Azure blob storage as our like a storage to store our store and like fetch the data to our Databricks. So it's like integrated within that. So the data pipeline architecture is based out of the medallion architecture. So we're having a bronze table, silver table, and ideally a gold table. So we just get the raw data from the event hubs and store it in our bronze layer. So
Mhm.
after that, what we do is we do a basic level cleansing on that raw data by filling out the missing timestamps and like treating the outliers and all. So after that, it gets pushed into the silver table where it is at a high level aggregated. So in this specific project in what I am working, there are like ideally two silver tables. So we are having two models to predict the next day's like the power prediction. So one model is accurate to the next 4 hours window, and the next model predicts for the next 24 hours window. So ideally what we'll do is we are having two separate silver tables, which would be input into two separate data science algorithms, which will predict for the next 4 hours and 24 hours respectively. So we are having a separate silver table flow for each of this. And the weather data, coming to the weather data part of it, since it is like a streaming data, we are using DLT pipelines for it to handle effectively the CDC changes in that. So once these weather data and the meter data we have received it, we try to aggregate that and bring into separate silver tables. And then these silver tables are given as an input to the algorithm, which will give us two gold tables. And finally these gold tables are aggregated separately at a 4-hour level and at a 24-hour level, and this is merged into a final gold table, where I can be using that as my source for estimating the cost savings for the next few days.
What
Yeah.
kind of basic responsibility you have in your team? What is your day-to-day job?
Yeah, so since like the meters data flow in from like various sites, so there are like a lot of possibilities for for like data anomaly related data coming in like then and there. So we'll have to if let's say if a new site is kind of onboarded and like the data is not like flowing in as expected, so my role is to go and like accordingly cleanse the data, aggregate it, and make it flow as expected until the goal table. So each and every day I'll have to collaborate with data scientists and then like try to validate that the data which is flowing in is actually as expected. So this is like one of my day-to-day activities. Other than this, I'll have to provide them the required tables, and if they need any other data, then I'll have to fetch it from various sources within our organization and bring it to the Databricks layer, and also provide those those aggregated tables to them.
So you are using for streaming data, you're handling with the Delta Life Table pipeline.
Yes.
How you can manage the late arriving records?
Yeah, so basically, we are having this watermarking function. So this watermarking, we can specify like up to what time window we can expect for a late arriving data. So if data is gonna come late, and if that falls within our specified waiting period, then those data will be automatically handled using that watermarking option, which is available as part of Spark.
Okay, let's discuss about something else. Suppose you have 1000 TB of data, or maybe 1000 GB of data you are handling,
Okay.
and you want to configure your cluster such a way that you should perform in an optimal state. So basically, I wanted to understand what kind of cluster configuration and what kind of basic thumb rule you will apply when you are starting a cluster configuration. What kind of executor memory you will have, numbers of executors.
So based upon the size of data, the partitions that we are gonna take up, and then the kind of the CPU cores and like the memory that we are going to use as part of clusters, right? So those
Mhm.
things we'll have to take into consideration, and we'll have to ensure that the executor like the executors within each node, right, they are properly distributed, so that like we make full use of those resources, so that it can efficiently handle parallel processing in it. So like these are like one of the like few of the factors which I would consider. And also the storage, what it's got like we are having on heap memory and off heap memory and all, right? So based
Mhm.
upon the type of data that we are gonna process and how it's going to be aggregated, the transformations which we are gonna make, perform on top of that, say x amount of data. So we'll have to we can manually configure those things in our Spark session, so that we can effectively make use of the available resources.
Have you experienced any bottleneck in your project in terms of latency, and how did you resolve this? If
Yeah,
any?
so there was this one particular situation where my the power prediction data was used to dynamically adjust the loads in the building. So for that we had to take instantaneous actions based upon the predicted power demand. For that, in Databricks, we were using it based the jobs were running using a traditional job scheduling cluster, but we had this bottleneck of cluster start time. So since this had to be like an instantaneous reaction, and we had to get it reflected instantaneously, so we were having that bottleneck of like delayed action on it. So what I tried to do is, there was something called this cluster pooling option. So there is something called like this always on cluster available option. So I had went through those documentation and explored on that, and then even though we had to compensate on the cost side, implementing that always available cluster helped us address this issue. So that was like one of the things that recently I had faced as a challenge.
How much the data you are dealing with the pipeline?
So basically, at a weekly level we handle about 500 GB data.
Okay.
Yeah.
And suppose you are handling your 500 GB data and your pipeline has been optimized to handle that kind of load. But suppose the load has increased and you are seeing some kind of slowness, or maybe you are seeing out of memory issue in your logs. So how will you handle, and what will be the troubleshooting point? What will be the consideration to understand from where your code is breaking? What the steps will follow?
Yeah, so basically we can increase the resources either vertically or horizontally. So like the number of resources and the compute resources can be increased by compensating on the cost to handle these these out of memory exceptions. And the other thing that I would probably look into is the type of the basically the partitioning of the data and how it is there. So if it is properly partitioned and Colis and Wacom and all these kind of optimization tools are on top of the existing data used, and if that is checked, maybe then we can decide whether we can scale it up vertically or horizontally based on the resources, or we can proceed with these implementations which we have looked upon.
You worked on any PySpark optimization techniques or any optimizations like that?
uh, No, I have not predominantly worked on code level optimization techniques, but as a rule of thumb, we are having this scheduled job which runs at each and every day, which will optimize vacuum the tables which are having unnecessary records, and it will run at each day once, thereby cleaning up the table and not like discarding the unused records which has been for a long period of time. Yeah.
What is optimize command and how it works?
So optimize command, it basically uh, uh, like uh, it optimizes the table which we have created. So it will try to efficiently query that particular table by co-locating the records properly. So like whatever the records which are like frequently accessed, right? So those will be like cached, and like we can query the table the next time when we are going to query the same table. It will ideally help us in querying performances.
Okay. So what are the different join strategies available in PySpark?
So there are like two major join strategies. So one is the broadcast join. So if you are going to join two data sets, and like comparatively one data set is like very significantly small in its size. Let's say we can accommodate it within one specific node, or like the executor memories, like the in memory storage. So if it is like kind of proportionate to that, then we can go ahead and use this broadcast join, so that the shuffling can be rectified, and locally the joins can be made within the like the nodes. So the if the another one case is like if both the data sets are huge in size, then we can go for sort merge join. So basically, the based upon the common columns which we join, the data will get sorted, and after that the data will get merged. So this will ideally help in also reducing the skewness of the data with that which we will be handling.
Suppose you have two tables. One table is 20 GBs of data, and the table is 30 GBs of data. These are two tables. And if one table is small, you can apply for first one. If two tables are large, both, then what kind of optimization techniques you follow so that shuffling is in a certain way may be reduced?
So while like that's what, so like when we are trying to join two comparatively large data sets, we can opt for sort sort merge join. So that will ideally sort the specific based on the specific common columns, and then the join will be performed. So like that is one of the ideal cases where we can use this type of join. And the next thing is the order of execution, and the columns which we can also select only the required columns which are like necessary for our output. So this column pruning also helps, since mostly we will work on parquet files and the delta tables, right? So the column pruning also helps in ideally like significantly reducing the query times and in executing the transformation.
Okay, so maybe you can also bucket those based on the column. So that is actually called sort merge bucket join. So you can first bucket, and after then you can apply the joins. So bucket will maybe reduce the shuffling in terms of if you do it before the join. So
Okay.
that's one point you can take the consideration. Okay, fine. Suppose you want to create a pipeline.
Okay.
So the requirement is like you have a on-prem DB. So
Okay.
as soon as some transaction happen, okay, we want to capture the transaction. Maybe there is some update, there is a insert or build happening that on-prem database, maybe in a SQL server or Oracle server. Even after the processing the data, you have to take that information, store in a data lake, or maybe in a data lake first, and you want to reflect the same in a live dashboard. So the flow is there is some transaction happen in an on-prem DB. You have to take down that information first, put back into a data lake. You have to process the data based on some aggregation, some KPIs, and then out of that you have to create a live dashboard. So whenever some happens, the dashboard reflects that change. You have to design this pipeline. What kind of component you will choose if you have to do in an Azure ecosystem. So you can just explain your thought and we can discuss about it.
Okay. So basically, to set up this kind of a pipeline, we will primarily need to identify how our data is going to get orchestrated from our source, and where we will be like a potential solution for storage, and like, and on what kind of platform are we going to make use of these transformations, and then finally to get that insights, right? So this needs to be connected to any one of a kind of a business intelligence tool. So we'll have to like ideally choose one solutions for all of these flow, like, so coming in chronology, this the orchestration tool, let's say we can have either like Apache Airflow, or the Databricks event hubs, like the connection strings, how we connect from our source then to our platform where we are gonna transform and make use of these transformations and triggers and all. So after that, this needs to be the data which has been stored like sourced fetched from the source, right? So after making transformations, the ideal, like the final goal output table needs to be stored somewhere in a storage. So for that we need to be choosing what kind of a storage option that we are going to explore. Then we will need to be connecting the same to one of the business intelligence tool. So what business intelligence tool will be ideally good for driving insights from this aggregated crisp of data, so that we have to decide. And also, while we'll have to ensure on the security part that we are having this in data is at encrypted at rest, and while it is in motion. So all these kind of basic things we need to have in consideration while setting up this end-to-end pipeline.
Just a quick follow up. I just wanted to understand one thing. The scenario is like you want to implement a CDC kind of thing, but the CDC is happening in your on-prem side. Okay, now you want to just understand like what kind of transaction is happening in your on-prem SQL server, and you want to take that change in a in a streaming manner. Okay, so it will be a kind of a live stream kind of thing. So how do you implement this? What kind of tools you can explain, or what kind of design is coming here?
uh,
So whenever some insert happens in a SQL Server tables, you want to capture that change. It will flow in live, and it will have that data in your SQL in your data lake. And after that, from the data lake, you can have an ingestion tool. Maybe you can put down data bricks. You can process that data. You can process that, and after that, you put it in a data warehouse. Some other power you can plug into data warehouse. That portion is easy and simple. The challenging part is from on-prem, you have to take down the data in whatever that is happening, you have to take it the data in a live stream manner. So, any idea, any thoughts on that? How will you capture those data?
so we can implement slowly changing dimensions.
Slowly changing dimension is first. Then, see, there are two kinds of things. One is Spark streaming, and another is batch processing. So, in batch, we are processing the data batch by batch per our batch. But if I want to have that data in a lively manner, so whatever is happening, I need the data in that point itself.
Okay.
But the connection is from on-prem to cloud. It's
Okay.
something, and you now you want to have that effect in the cloud itself. So you have to merge that. If it's a batch manner, you can maybe have an ingestion pipeline which can run per hour. You're taking all of those data. That is fine.
Okay.
But in case of live and data handling, have you worked on any kind of scenario or say any thought?
As of now, I have not worked on those kind of things. Yeah.
Okay. Okay, let's discuss some SQL questions. I'll give you link in the chat, or maybe I can copy this data set and then I can explain. Then write the link, the query by sharing the screen. Okay, so I have pasted a data set and sample output in the chat. Can you see it?
Yeah.
So we have this table, person, type, and age. Okay, so the output should be there will be two columns, adult and child. So oldest adult should match with the youngest child.
Okay.
So if you see the oldest adult is A4, the youngest child is matching with the C4 based on their age. Okay. So you can share your screen.
Okay.
And start type query and yeah. So we have this table, person, type, and age.
Okay.
You have to match the oldest adult with the youngest child based on the age.
Okay. So.
It's in a descending order.
Okay. Got it. Yes. So I think I'm done, Ankur.
You can explain a bit what you have done.
So basically, I have created two CTs. So the first CTE will use the row number functions in the window function, which will store the data for only the type is equal to adult, and it will order by based on the the descending order, and the ranked child with ranked child, which is the second CTE, uses the same row number over function, and it sorts the data by in ascending order. Then what I am trying to do is I am doing a full outer join so that y- like uh, like no records will be missed out of the data sets, since like they both will have the ideally the same schema. And then I am trying to order it by the row number which I am having, which I have got as a result out of this the first row number function, and then the second row number function. So this will ideally try to mutually match according to the output.
Mhm. Thanks, Srinivasan, for attending the session. We'll share the feedback.
Sure. Thank you, Ankur.
Thank you. Thank you.
It was nice meeting you. Bye.